So in the previous video, we did an introduction to this Apple II Rev 0 clone board and took a quick look at the parts that I had purchased to go along with the board. And I'm going to follow along with the assembly manual that Mike wrote up here in the order that he basically said to do this. And the first thing he said was to do a hard inventory of the parts. I'm going to skip that. I'm going to assume I have the right stuff. If we discover stuff we're missing along the way, I'll either have it here in my stock or I'll need to talk to Unicorn Electronics if they manage to not kit it somehow. So the first thing they want to do is check for power and ground shorts on the PC board itself. And that's actually a really good idea at this point. So let's go ahead and get our meter out. And let's just look for any shorts anyplace. I need to go to continuity mode. There it is. So let's get this oriented the same way. Grounds. So it looks to me like the orientation of this connector is here. These should both be grounds, and they should wrap around the board, and the ground goes to the outer conductor on the video connector. So those are both grounds. I should not see a short any place to these other 4 pins here. If I do, there would be a problem on the PC board. And I'm also going to look between the combinations of these. We're doing some repeat checks here, but this just assures me that I'm getting through all the combinations. So I don't see any issues there. Let's go ahead and just gently walk down these. There's a lot of bus leads in the board that run between these that are pretty narrow, and the spacing between the solder joints here is pretty narrow. So just in case there's something wrong there, I would expect to see continuity. Most of these pins are parallel. Oops. So I don't think there's any shorts necessarily in the printed circuit board there. We've got the same condition down here in the RAM, where there's lots of traces running between the solder pads. I don't want to see shorts on those. That's pin-to-pin parity. I expect that. Again, I shouldn't see shorts here. Shouldn't here. That's probably a power supply rail, why it's common to all locations. Though I don't know that for sure. So I'm not seeing, again, where there might be defects in the manufacturing of the board. I'm not seeing anything that would speak to that there's a manufacturing defect. You know, again, that's a common pin. This is the same thing. It's the same kind of thing where there's a lot of wire, a lot of traces on the board, and some of those run, a lot of them run between solder points. That all looks normal to me. I don't see any real issues there. So from things that are really super high level I can do, I think that board looks good. So he starts out by saying one of the key things here is to check the orientation. Make sure you don't put a 14-pin socket in a location for a 16-pin socket. I've talked about this in other assembly videos. And then over the years, I evolved the process of start with the largest sockets if you can. So I tend to populate, for me, the 4 corners of the board first, whatever size sockets those are. So, you know, these 2 locations here and probably here are probably what I will solder up first. That way when you flip the board over to work in the middle, the board's not rocking around on that socket. It gives you a little bit more stability. So that is a difference in my approach to Mike's here. But what he does is the same thing I like to do. He starts with the 40-pin socket. There's no way to get the 40-pin socket in the wrong spot here. I guess maybe it might drop into, you know, some area here, but that'd be an obvious script. So he's going to work from the 40-pin to the 24-pin to all 63 of the 16-pin. Holy moly, that's a lot of sockets. And then to the 14-pin, and then the 2 8-pin. So he's working from the largest socket to the smallest. And this to me becomes critical. You cannot put a 16-pin socket in a spot for a 14-pin socket. It physically won't go in. But you can drop a 14-pin socket into the spot for a 16-pin socket. And you can offset it, you know, high or low in the socket. I've done it. And then I've been all crud unsoldering a socket, you know, a 14-pin socket I put in a 16-pin location. And ages ago I evolved the process of largest device to smallest device as I stuff sockets, with the exception of addressing the corners, just because I think it makes it a little bit easier to address. That looks like it's probably 16 pin, 16 pin, 16 and 16. So let's pull out some 16 pins here and be very careful to make sure that we're not messing up. These look like nice sockets. The pins have a gold. Oh, maybe they don't. Well, maybe they do. The pins are definitely silver, but there's a hint of gold color on the top. They look like they're quality sockets. That's definitely a 16 pin location. I've got instructions to notch go. The notch on every one of these, the notch goes down. I believe that's a 100% true rule. I'll find out as I build. I've got one over in this corner that I believe again is a 16. It goes in well. Your preference might be to follow instructions exactly. Your preference might be to start with the resistors because they're the lowest profile. That's also a completely legitimate way to do this. There's a spare socket down here in this corner that is not used. So I'm not going to drop anything into it here. So this is actually a 14 pin here. So this is a 16 over here. And it's got a 74 LS 175 it looks like in it. So I'm going to go ahead and put that socket in there. See, I'm not going to fill that extra socket. This was really common back in the day to see kind of a prototyping or a fix area and actually extra socket footprints if they could fit them on. So it was really common, especially on first runs of boards. Those look like they're probably 16 again as well. But just really common. Like I say, especially in the early runs of boards when you didn't know if it was going to be correct and you might have to do some rework, and having some extra socket locations or some prototyping area was really useful. So, I'm not surprised to see that. That looks like a 14 pin to me. That looks like a 14 pin location. I do believe we're absolutely fine there. So I found some blue tape. I know I've got a better roll someplace, but this will work. Soldering pencil is heated up. Let's go ahead and see about soldering these four guys up. So they are sitting proud here on the board because the board is laying down tight against the work surface here. So they are not able to drop completely down. Oh, that didn't tear down the middle the way I would have liked, but such is life. But when I flip it over here, pins should push all the way up through. Like I said, this is my preference. When I put the 40 pin socket in, I'll still want to hold the board down tight against the socket. It just, to me, if I start with a 40 pin socket, the board would rock, and I just don't like that rocking without the support at the edges. That's me. Approach this the way that's best for you. I know that I'm getting out of the video frame high and low here. I'll try to keep things centered in frame. We have solder. We have the wrong tip on the soldering pencil for this. I will hot swap to the right tip. If I can get a hold of the solder, we will hit a corner. And we are officially started. I started to lean on the board and put weight on it, and that started to flex the board, and we don't want that at this point. Not at all. Again, I'll hit two corners down here. I'm assuming the square pad is pad 1. I don't know that as a fact, but I'm guessing that to me is the norm, and I would expect WAS to have done that. Or is it ground? So the square pad's only on the back side, so pin 1 would be down in that corner. Yep, square pads are pin 1. So that's excellent. Let me peel the tape off. And set it aside because I'll reuse this for many, many sockets. And let's just take a look here. That looks nice and flush. I can conceivably reflow these. I want to be careful not to burn my finger. And push up. He didn't move. He didn't move. Ouch. I did manage to burn myself a little bit. Yeah, at least those two were in nice and flush. So I am obviously not going to solder all however many of the sockets is in a super long, super boring video. But we will start a couple more here together. So we've got our 40 pin guy here. Let's go ahead and remove the tape that they've used to hold it in the tube. To me, these are called rails. To most of the world, they're apparently known as tubes. Back when I worked at National, we had lots and lots of metal IC rails. They had a slot down the middle because EEPROMs went into them, and you needed the slot down the middle so the UV light could get in to erase the packaged parts. And I put a lot of EEPROMs into those rails, and a lot of EEPROMs got pulled out. So there is the main 6502 socket. The socket looks to be in good shape. I'm trying to figure out if there's an orientation to this socket. It's obviously going to go there. So I'm curious if it would fit accidentally. No. So these are not quite on 600 mil centers from like right side to right side. That was just curiosity. I'm going to assume it goes in that orientation. The notch is to the left here. I'm trying to figure out what marks the orientation on this socket. There's a dip in the cross member there and one there. There's nothing here that really yells at me as this is pin 1. There's no corner on the socket that's got a bit of an angle to it. It's very, and it's not symmetrical because of those notches. Is it more appropriate in this direction? That looks unique there. Maybe. Will it sit in place while I flip the board over? It actually might because of the size of it. And see, the board's nice and stable here with those corners. So I'm putting a little pressure on the board on both sides of the one pin I'm going to tack here. And I'm going to do the same thing down here. And that socket should be in and nice and flush. And it looks nice and flush. I don't think I'm going to spend the time. I don't feel any slop in that. We've got 24 pin sockets that look like they are all identical. There's not like a different one here that I would use down. So there's 6 of them here and there's one down here. So character generator ROM and the system ROMs. And it looks to me like all 7 of these sockets are identical, so it doesn't really matter. If there was one that was different, physically different, I would use it down here to keep the sockets for the ROMs up here all consistent. See, boy, I keep rotating these with the notch up. It is just so ingrained in my brain. Oh, there's 7. I was going to say it was short one. There's all 7. I got to be vigilant here. 1. Yeah, these are nice sockets. Like I say, that's an auget socket. I suspect these probably are as well. Yeah, AUGAT. These are quality sockets. These are not, $100 for $1 sockets. They are not cheap sockets, and that's part of the cost of this particular package that I bought, is the fact that these sockets are just not inexpensive. These machine pin sockets, but they are a much higher quality socket if you're going to socket things. Some people are absolute purists and say you should solder the ICs directly in for the best reliability, and they may be right, but in a build like this, no. No, I don't know that all the parts are functional. There's a lot of vintage parts that are going to be used in this that are, well, 82 seemed to be a pretty common date code when we looked at the ICs. So that would be 40 years old. That's a pretty old part. New old stock. It's been sitting on one or more shelves for 40 years before it was pulled, to be included in this, the parts package I got. And I don't know how it's been stored. I'm assuming it's been in a nice temperature and humidity controlled warehouse. Odds are it actually hasn't. Has it been through freezing cycles? Has it been through high vibration? Was it on an airplane? Etc., etc., etc. All those things can lead to parts. Now, this is interesting. You need to keep it in mind. Pin 1 on the processor is down in this corner. The notch is over on this end. And for the character generator, the notch is on the other side over here. So pin 1 is actually there. And interesting enough, he's rotated pin 1 in the pads. I don't know if you can see that. See if I can get up here where maybe you can see the board. Pin 1 there's a dot by it. Actually, there's a dot by all the pin 1s. I've just noticed there's a dot by pin 1 every place on the silk screen. That's a wonderful detail. So, but pin 1, this guy is rotated 180 degrees from this guy, for whatever reason. So I want to again get the socket in with the notch in the right orientation. Hopefully I can hold that in place long enough to get the board down on. I can actually see that I can press the board down quite a bit to get it to touch the bottom of the package. So I'm going to hold it down with this finger here while I solder that first joint. And then I will hold it down again. Otherwise this socket would have set proud had I not done that. Socket looks fully in. The pins seem to be up flush on the board. On the corners where I didn't solder, I don't feel the socket moving in any way. So these sockets are tacked in place. And now it's just a matter of soldering in the field for those sockets. So I don't intend to do video for the rest of the sea of sockets here. It's just going to be a rinse and repeat. Everybody else here is a 14 or 16 except for the two 8-pin. There's an 8-pin there, 741 C op amp. And there's apparently one more 8-pin that in my memory is down here someplace. Yeah, right here. 555 timer. Again, I have memories of working on the non-fixable Apple II board that we fixed. Love it when it's cheap on eBay because it's beyond repair. Parts only. We made it run together, so it was not unrepairable. Anything else to talk to here? I'm just looking at where parts are. That 27 microhenry inductor we saw. There was an inductor in a bag. Obviously goes there. Lots of resistors. Trim pot, obviously where it goes. The trimmer cap is down here. That is labeled for a trimmer capacitor. Color trim. Actual 8T97s. They can be replaced with a 74397, I believe. But the 8T97s are the predecessor. They're the more appropriate era part. Same thing with the 8T28s. I don't remember what the replacement for those exactly is. As we get into stuffing the logic, we'll find out. don't think there's much more to talk to in this video. The build has begun. So I hope to see you in a future video, and we'll talk soon.